Okay, we're looking at problem 4 now. So they want us to determine the currents I1 to I4. So 1, 2, 3, and 4. Okay, and we see that we have a current source here with 6 amps. And to determine how that's going to look, we need to see that, okay, our current's going to come up through here, hit that point, send some off that way, and then send some off that way. And then it will come down through here, reach this point, send some that way, and send some that way. So every time it hits one of those little junction points, it'll break off the current. Currents will meet back up. Here, there, and they'll come back here to form 6 amps. Okay. The question is now, how much breaks off this way, how much breaks off that way, and then how are they broken up into I1, I2, I3, and I4 after that. So to do that, we gotta first figure out how much everything is in the sense of everything going to the left and going to the right. So I'm going to call this current I right, call this one I left. Okay, so I left is going to break up into I1 and I2, and then I right is going to break up into I3 and I4. All right, so when we do that, we're going to need to figure out the total resistance of the entire circuit, okay? Because it looks like that is going to be in parallel, and this will be in parallel as well. I'll call this one parallel 1, and I'll call this one parallel 2. Okay, so we'll do R parallel 1 is going to be equal to 2 times 4 over 2 plus 4, which looks like it gives us 1.33 ohms, and then R parallel 2 will give you 2 times 4 over 2 plus 4 is equal to 1.33 ohms as well. Okay, so if we go and redraw that real quick. Okay, there we go. So R parallel 2, R parallel 1, and we still have 6 amps, I right, and then I left. Okay, and then it looks like that both of these resistors are also in parallel, so I will call this I parallel or R parallel 3. So this would be R parallel 1 times R parallel 2 over R parallel 1 plus R parallel 2. And that'll give us 1.33 times 1.33 over 1.33 plus 1.33. Okay? And that is going to be 0.67 ohms. Okay. So we now know that R parallel 3 is equal to R equivalent. So now all we need to do is use this piece of information to determine I left and I right. So I left is going to be equal to R equivalent over R parallel 1. Left is going to be this entire side here, okay? Because that's the side we're going down. So all the resistance on that side times 6 amps. Actually, we'll write source first. So I of S. So when we do this, we'll get 0.67 ohms over R parallel 1, which we found was 1.33 ohms, and then we have 6 amps. And this will give us 3 amps for I of L. Okay. And if we did I right, it would also be R equivalent over R parallel 2 times I of S. And R parallel 2 is just because it's everything on this side. So all the resistance on this side of the circuit. All right. And this will also give us 0.67 over 1.33 ohms times 6 amps. And that'll give us 3 amps for I of right. All right. So now we know what I of left is. We know what I of right is. So now we can come down here. Look, I'll redraw it again for us. So we know that I of left comes this way. It'll split off into I2 and I1, where we'll have 2 there, we'll have 4 right there. So using our same current division equation, we can do I of 1 is equal to R equivalent over R2. In this case, R2 is the R2 ohms, times I of source. This will be R parallel 1 over R 2 ohms times I left. Okay, because the source current is whatever's being broken up, and in this case, it's the left current. So if we just go sub those values in, we already found R parallel 1 and R parallel 2, so we can just drop R parallel 1, and then we'll put that over R2, then we'll multiply by the 3 amps, and we will find that I1 is equal to 2 amps. That is equal to I1. All right. We'll look at I2. So I2 is equal to R equivalent over R2 ohms times I of S. Oh, sorry. That's supposed to be 4 ohms. 4 ohms. Okay. So this will be R parallel 1 still over R 4 ohms times I of L. So once again, this will be 1.33 ohms over 4 ohms times 3 amps, and this will give us 1 amp, okay, which will be equal to I of 2. All right. Okay, so now that we figured out what I1 and I2 are, let's take a look at I3 and I4. So I'll scoot down just a little bit. Okay. So same deal as before. We're going to have I right come down, and it'll break off into I4 and I3. Okay. And something I want you to notice is, so I of R is also equal to 3 amps from right there. All right. And look at the 2 branches. There and there. They're identical branches, right? So we really can just bypass doing all that work again, because we see that the 3 amps is going to be broken up down a 2 and a 4. And like we had up here, this was 3 amps, which was be broken up down a 2 and a 4. So we've already done the work. We can just say I of 3 is equal to I of 1, which is equal to 2 amps. And then similar, I of 4 is equal to I of 2, which is equal to 1 amp. Okay. And if you really wanted to go back and do the work for it, I of 3 is going to be equal to R parallel 2 over R2 ohms times I of right, which would give you 1.33 over 2 ohms times 3. And then I of 4 would be R parallel 2 over R 4 ohms, I of R, which is equal to 1.33 ohms over 4 ohms, and then times 3. So that's, if you wanted to go about it that way, that's perfectly fine too. We can just notice that there's similarities between the two sides, and we can bypass doing extra work.